Hello everyone. In this video, we're going to discuss about machine instruction and computer instruction. So machine instruction, basically the computer will perform all the operations only we give any instruction. So only through the instruction we can able to perform all the computer operations. So here we're going to discuss about what is meant by machine instruction and what is actually computer instruction. Machine instruction, so both will differ only in their representation. So it means machine instruction will be represented in mnemonic label, operand followed by comments. So mnemonic label, or it is also said to be mnemonic code, which is nothing but one specific code that is used to represent the instruction, what kind of instruction it is, and followed by operand, in which of the operand you're going to fetch the values, data values. So that may represent this operand. So either from the register or from the memory location, in which of the location we're going to fetch this operand. And followed by comments. This is actually optional, so that's why it is given in the bracket. So it is optional, it may or may not given by the user. So first, this actually represented in assembly language. So assembly language instruction can be understood by both the user and the machine. So here let us see one example for this machine instruction. Here we have move instruction, MOV, so which is nothing but the mnemonic label or the code, and followed by the operands. So here it is given two register operands, R2 and R5. So what is the main operation of this instruction, move instruction, which is nothing but data transfer instruction. It is of type data transfer instruction, which means transferring the content from one location to another location. Here we are transferring the content from R5 to R2. So here we have two register. One is used to denote the source and another one is used to denote the destination. From which location we are going to transfer to which location we are going to store that content. And another example which represents move R2, #25H. It means it is one of the location which is stored in the memory. So it is one of the memory address. So in that address, whatever the content we have, that will be transferred to this register. This is what this instruction, move instruction. So we're going to move from one location to another location. What we're going to move? The one that is nothing but content. That is the data value. It might be any of the data operand or any kind of instruction. So this is nothing but machine instruction. So here this source and destination may vary. So in some textbook it is given as this is actually the source and this one is considered as a destination register. In some textbook it is given as this is considered as a source and this register considered as a destination. So it may vary in different machines. According to the basic design of the computer hardware, it may vary. So let us see what are all the major categorization of this machine instruction. First one is data transfer instruction and data manipulation instruction. Last one is program control instruction. So what is data transfer instruction? So in order to transfer the content from one location to another location, so the location, it might be any of the register or even the memory address. So it might be anything. So if you are transferring all those instruction or all those instruction which can perform that kind of operation, which is nothing but data transfer instruction. Data manipulation means it is again categorized into arithmetic, logical and shift instruction. So data manipulation, it means if you are performing any operation on the given data, if you want to perform arithmetical operations such as addition, subtraction, multiplication, division, like that, and if you want to perform logical operations and or operation or all the logical operation that can be done, that can comes under this category. And shift operation, so shift, if you want to perform shift operation on the given data, then it comes under this category, that is data manipulation instruction. Next one is program control instruction. Program control, or it is also said to be transfer of control. So if you are transferring the control, not the data or the content, if you are transferring the control, usually your CPU will execute the instruction that can be fetched from the memory sequentially. So it will execute sequentially all the instruction. Suppose in the middle of executing all the instruction, if it gets any interrupt or if it is not getting interrupt, so if it is executing any other instruction like branch or call or return or any function call instruction, so like that if it is executing, then it comes under this type, that is program control instruction. So in such case CPU will not be executed sequential execution, so it will switch over to some other location. So that is what transferring the control from one location to another location, that is what program control. So this is about the machine instruction, how we are representing the machine instruction with the help of this mnemonic code followed by the operand list and followed by the commands. Commands is optional. And the next one is it may or may not be given by the user. Suppose if they are not providing the command, no problem. By seeing the instruction itself, we can understand what kind of operation we are going to perform. So that is what the mnemonic label represents. So and also this mnemonic code may vary, depends upon the machine. In some machine they will be given it as MOV. For the same instruction it can also be represented as MV. Right. Next one is computer instruction. So what is actually computer instruction? So how we are representing this instruction, the same machine instruction, how we are representing in machine language. So machine instruction usually will be represented in assembly language. If you are representing in machine language, then you should follow one specific instruction code format, which is nothing but instruction format. So how we are representing each and every instruction. If it is a 16-bit instruction, how we are dividing the instruction code? We are dividing the instruction format into 3 sections. First one is address part, next one is opcode, and another one is mode, which is represented by the symbol I. So what is this address part? Address part means if you are fetching any of the operand, so where that particular operand is located, whether it is a memory or it is a register, or even if you can able to interact with the peripheral devices. So if you are getting the input from the input devices, then how we have to represent it. So this particular part is used to represent either you are fetching the operand from the memory or from the register or from the input-output devices. So here if you are fetching the operand from memory, then it is of type memory reference instruction. And what is the next one? Opcode field. So this opcode field is used to represent what type of operation you are going to perform, whether it is add operation or division or any logical operation or any shift operation. So like that, which kind of operation you are going to perform. So that can be represented with this part. And the next one is mode field. And this particular field has been designated by the symbol I, which is used to represent what kind of memory reference instruction it is. So basically this memory reference has been divided into 2 types. So one is direct memory address and another one is indirect memory address. So what is direct memory address? If it is of type direct memory address, then the value of this I is 0. If it is of type indirect memory address, then the value of this I is 1. So only 1 bit will be assigned for this I value. If it is 0, either 0 or 1. So let us see if it is a 16-bit instruction. So how we are dividing the bits for that particular field. For the address field, only 12 bits will be used to represent. For the opcode field, 3 bits will be used to represent, and the remaining 1 bit will be used for this I bit, used to represent this I bit. So here, and what could be the value of opcode field? So it seems it is of 3 bits. So the number of operation can be done in this basic computer that comes under this memory reference, which is nothing but 8 number of operations. So that 8 number of instruction can be executed. So because if it is actually holding 3 bits, 2 power 3, which is nothing but 8 number of instruction. So here if you are providing the values for the 3 bits opcode value, which is 0. So if it is 0, it is a direct. So I will tell you about direct and indirect after explaining all these computer instruction categories. So here if the I value is 0, it is of type direct, and the remaining opcode value all 0. Okay, so then we need to perform AND operation. And the next one is, so it is already defined thing. So while designing the computer hardware or the architecture, so in that it is mentioned that this specific code will be used for providing particular operation for executing this AND operation. For execute add operation, so we need to represent this particular code. And for so for load and for move, like that many number of instruction will be executed according to this particular code. So here it is represented, it goes on up to 6, 0 to 6, okay, 0 to 6. So that is the opcode field for the direct address. And from 8 to E, so it is actually all those are said to be binary values. All those values will be represented for opcode field. So if it is for direct address, it will be represented from 0 to 6, and for indirect address, the I value could be 1. So I value could be 1, and the remaining opcode values will be represented as 8 to E. Then that particular AND or add or load move, so that particular instruction will be executed according to these values. This is about memory reference instruction. Next one is register reference. In this register reference instruction, we are not going to contact with the memory while for executing the instruction. So we are going to fetch the operand only from the register. So that is what it got the name register reference instruction. So here we have the opcode field which remains constant for all the instruction, that is so this opcode value is same for all the register reference instruction. It remains constant. And what could be the I value? So here it is not mentioned for representing the direct or indirect, because this direct and indirect mode will be used only for the memory reference instruction and not for the other two types of instruction, that is register reference. So this value will also be same for all the register reference instruction. We will be having many number of register reference. Some of the register reference instruction are listed here. One is clear accumulator, CLA, which is nothing but clear accumulator. Clear E, so here E is nothing but the carry bit. So if you want to clear the carry bit, you can execute this instruction. This is complement A, complement accumulator, complement E, complement carry bit, circulate right, circulate left. All these instruction belongs to shift type, shift instruction. This one is increment. Even if you don't mention the operand, it by default it should be understood that this increment operation can be done on the accumulator. So these are all some of the register reference instruction. For all these types of instruction, these 4-bit values are same. But what is the address part? So here we are not going to fetch any of the operand from the memory. So we are not going to contact with the memory. So it is not said to be the address part. So one specific value will be provided in order to represent which of this instruction we are going to execute. Which type of register reference we are going to execute. So based upon this value, we can differentiate all those instructions. Similarly, input-output instruction will also be executed based upon the values whatever we are providing for the address part, and the remaining 4-bit values are same for all the input-output instruction. So here I value is 1. It remains constant, and the remaining 3 bits also be constant, that is 1, 1, 1. And this address part, which is not said to be the address part here, this specific code which is used to mention which type of input-output instruction. So here some of the input-output instruction, this is used to input a character, and this is used to output to the character, that is the character will be transferred to the output device. This is nothing but skip on input flag, skip on output flag. So here one flag bit will be used to represent the input and the output flag, and if you want to skip on that input flag, then we can execute these two instructions. So now I am just going to explain about the memory reference instruction. So how we are dividing the instruction into direct and indirect. So in the memory reference instruction, it could be represented in this format. So this is address part, opcode part, and this one is I, which is used to differentiate which type of instruction it is. Suppose if it is a direct address, so what happens here? There will be storing one instruction in this location 22 for your understanding. So I am just giving this location in decimal format, but it should be represented in binary format. So here it is a add instruction, and whatever the address we are getting in the address part of the instruction, if you search in that particular location, you will be getting the operand, and that operand will be add with the accumulator, and again the result will be stored in this accumulator. This is what direct address. In this indirect address, the instruction has been stored in this particular location 35, and what could be the I value, that is 1 because it is of type indirect, and what is the address part of this instruction, that is 300. So if you search in the 300th location, we will be getting only the address and not operand. If you don't get operand directly in this particular address part of the instruction, so if you get only the address, and again you need to search in this particular location in order to get the operand. Finally, that operand will be added with this accumulator and the result will be stored again in this accumulator. This is what indirect and this is direct. So it is all about machine instruction and computer instruction. Thank you.